Hi everyone, welcome to one of our Hangouts with Desmos. We've got a very special one today. We have two guests here, Justin Lanier and Dan Anderson, for this Desmos Live. These are two math teachers and also two of the creators of Daily Desmos. So I don't know if everyone watching has heard of Daily Desmos, but if you haven't, you should go to dailydesmos.com. Probably my favorite site on the web right now. Well, maybe top two. I'm also a big fan of desmos.com. But when I first saw this, it was, what, a few months ago. Got an email, saw this Twitter stream of teachers starting to post challenges for each other and for their students, and said, can we use the name Desmos in dailydesmos.com? And I looked at it and I'm like, oh my God, of course, this is incredible. And it's been just so much fun to watch the spike of people using Daily Desmos as a way of just exploring math and working with their students. And so we're so happy to have the two of you here, and I'm going to let you take it away.
I'm Dan Anderson, and this is Justin.
I'm Justin Lanier. I teach math for the past 7 years. That's happened at St. Anne's School in Brooklyn, New York. And you can see our links to our blogs on the webinar links page that we've sent out to y'all.
So I think the best idea would be to follow along with the links, and you can click through and sort of put us off on the side and try to follow along with what we're doing with the Daily Desmos stuff. Go ahead and play around, solve a couple if we're being a little boring or something, but it should be fun. So I guess like the start on how we got started. It started off, I was playing around with Desmos because that's just so much fun. It was just something I really enjoyed doing. And I made this cool graph, and I tweeted it out, and it looked like this. Let's see if I can find it. So the first link was I made this picture.
So here's Dan's graph, and I guess you can say what happened with the creation of it, but Dan tweeted out a link to the image that he had created on Desmos and said, hey guys, can you create this? This funny kind of sign-looking, kind of sideways, parabola-looking thing, and I saw that tweet, and Michael Persson saw that tweet, and Sam Shaw saw that tweet, and Michael Fenton saw that tweet, and we all started working on it individually, and came up with things that we thought were close or that seemed spot on, and that was a lot of fun. We shared the things that we came up with Dan and had good conversations about it.
Yeah, and then Michael Fenton was the one that brought it up. He said, wouldn't it be great if there's we made a whole bunch of these. We put it all on one website. So it was all Michael Fenton's idea. He sort of said, well, I said, great, that'd be awesome. And so he put it together. He made the website. He got a whole bunch of extra contributors. We have a whole schedule and everything. So he was the one that was really the driver behind the wheel. I just sort of started the ball rolling, and Michael Fenton was the one that just got it all going. He did some great job getting that started. I'd like to talk about who else is involved who else helps out with posts. So it's every day, every weekday, we have someone new post. And so someone posts a basic and an advanced generally on most days. The basic puzzle is sort of aimed at sort of middle school students, high school students, and teachers looking for a nice puzzle maybe to use in the classroom. You can do linear, you can do polynomial, exponential, logarithmic, all that stuff is available. You can do implicit relations, make it a little bit trickier.
If you switch over to this screen, is it popping up for me now? Boom. Yeah. So here, Dan, you can keep talking. I'll scroll through these things.
Beautiful. So the basic idea was that we're going through, and you can have students try these. They should be accessible to students at some level. They don't need to be real whiz kids. They can just sort of plug through some stuff that they know and play around and find some stuff and go from there. And then there's also an advanced that's a really good challenge that's also given every day. The advanced, you can do pretty fancy composition of functions. You can do polar. You can do a bunch of stuff that can be a lot trickier to solve. There's still a bunch of our advanced that do not have a solution.
So this is today. So here's a graph that Michael Persson made today, where, oh, in this one we can only see parts of the graph, and we're supposed to try to get the rest of it. So we don't have information about the zeros, but hopefully just looking at where these maxes and mins are, that maybe that'll give us a way of figuring out how to make the equation for this graph. And if we scroll through here, here's a nice challenge that actually Eli made. So on Fridays, so our weekly schedule goes like this. There are 8 of us who post regularly. We're on a every other week schedule, which you can see in the links, the webinar links page that we made for you guys. And then on Fridays, that we get submissions from anyone. Anyone can submit a challenge, and Eli from Desmos created this one. And then the way that we communicate with each other or share our solutions is down in the comments. You get these people, and this is one of the ways in which using Desmos as a web calculator is really useful and fits really nicely with this challenge idea, is that people can share their graphs really easily and share their different solutions, which is pretty nice. So like I can go here, grab this, paste, and I should be able to see what this person came up with. Oh, look, there it is. Here's their solution, sine x over x. Lovely. You want to show one, Dan?
Sure. So I'll go to desmos.com. And let's click on another one. Let's look at like a sort of an older one, maybe. So we can go down. So every day there's 2 of them. So there's a pretty basic one. So this would be Michael Fenton posted this one. Pretty basic one. There's the trick here, I think, would be for students would be finding the correct radius for this circle. They'd have to know to use an inequality. But I definitely think something like this would be approachable for a middle school or a high school student who just learned equations of circles. So they would have to do a little bit of thinking on how to get that radius right. Or they have to do some thinking to get the center right or to get the inequality stuff. But overall, it's trying to get at a bunch of different levels. It's trying to get at students that are middle school and high school, and it's also trying to get at teachers and give them a good challenge. So another example of a sort of more creative type would be, this one's by Sadie. She gave a set of points, and she said, can you come up with an equation that goes through those 5 points? So a student that maybe just learned some sort of regression or that kind of stuff, they could try to try to get a solution that's very close, that goes through or gets close to going through those 5 points. They can do a bunch of things to try to get a function that goes through them. So what do you think, Justin? Do you want to try solving sort of one of these more basic ones, or you want to try to show the sliders? What do you think?
I want to toss out this one more thing, and then let's try one of the basics together. So here's another challenge. It looks crazy hard, and it was. I spent a long time trying to figure this out. This was submitted by Nate, and one of the things that's really great about Desmos for this kind of activity is the way in which, so I'm going to click on my solution, is that over here we can not only type equations, but we can also type some words in our description of solution process. And so not only do we get like, oh, look, here's how I started, and then I sort of describe my solution. I picked this idea from other people. I saw them using it that way, and I thought that was really, really cool. And it's something that I try to promote for my own students. It's the kind of, I want them to be able to describe their thinking. And so the 2 things go together really well. Desmos is great at giving you sort of instant feedback as you try out different functions or try out different parameters. We'll show some sliders in a minute. and so it's great for the figuring out part of things, but it's also a good medium for describing one's solutions, and I think that's really powerful. All right, let's try solving one of these, Dan.
So if you guys are following along at home, you can try to find 33b and then 42b, the two ones that we're looking at right now. So let's look at 33b. So this one's by Jessica. Jessica contributes. Let's see, when does she do? Jessica does.
Yeah, just make
Wednesdays.
sure we. Yeah, every other Wednesday. She's my counterpart on Wednesdays, and just to make sure we say everyone. So on 1 week, it's Sadie and Kate and Jessica and Michael, and then a guest post on Friday, and then the other weeks are Michael and Dan and myself and Sam, and then again the guest post on Friday. All right, so we're looking at Jessica's, and all right. So what does that look like to you, Dan?
Looks like a cubic to me. It starts sort of in the lower left corner and ends in the upper right corner.
Yeah.
And so it definitely looks like it's got some roots, so that's going to be very helpful to us. It doesn't look like we can guess what those roots are by looking at them, so we're going to have to do our best to try to figure out where they are. We can do some approximations. What I like to do before I even try graphing is get the window right. That a lot of times that can really help you to get the picture right in the end. You can see if you're right or wrong. So let's go to Desmos.
Let's see. So it's like -40 for x, and from -40 to, what would you say?
Yeah, it's
80?
like -40 to 80, yeah. So -40 to 40 in the x and -40 to 80 in the y.
Great. Yeah, and it's really easy to do that in Desmos up here with this little wrench. Haven't used that feature before. Also, whenever you're doing trig problems, you can switch to the radians and have the axes labeled with multiples of pi, which is really nice.
Absolutely. I'll turn projector mode on. Projector mode is a really nice mode. I use that with my smartboard quite a bit in class. It makes the lines a lot, like if you turn it on and off compared to, it looks like the type is small. Without projector mode on, it's really nice on your screen. With projector mode, it means the kids in the back of the class can see really well. The font gets larger. It's much easier for them to see. So what do you think for our roots here, Justin? What do you think for our roots? Is that how you want to start? What do you think? Do you agree that you think it's a cubic?
Yeah, I mean, it certainly looks that way. So let me switch back over to this thing. All right, so one way, so now you've got me thinking about sort of two different strategies. So there's we could go about it using roots, which is, I think, maybe the way to go here. But the other way that I was thinking about was trying to take a basic cubic graph and then like toss an X term in and to get that swoopy fashion. I'm moving my arms in the air, but you can't see them. Right? So I know that whenever I start adding X terms, then I get these sort of swoop things, and it looks like the whole thing has been shifted up, right? Because we've got it peaks higher than it dips down low. But yeah, let's do some roots. So certainly there's a root at 0.
Root at 0, okay. What's that look like, the one on the right? The positive root looks like what? That's 10, so that's 5, so like 3 maybe?
1, 2, 3. Wait, that's negative. Oh, I see. On the right-hand side?
Yeah, the positive root.
Let's call that 3.
And then what do you think
So
for
that's
the negative root?
I'm going to write it this way. Factored form! A really lovely thing about these kinds of the challenges we put out is that there are multiple solutions often, usually, and I tend to think that more textbooky kinds of graphing problems, which maybe we'll do some more compare and contrast with later, there's sort of one method for trying to get to the thing, whereas here our problems tend to have more different solutions, and then there can be really fun conversations about whether those things are equivalent or how they match up with each other, and that's super nice. So what do we got for this other root, Dan?
I was guessing it was like 6, maybe -6. Maybe, although it looks like it's, I don't know.
-6, sure.
We can try that for now. And maybe think of that. That one might be one we have to adjust.
Okay. Oh, by the by, we are fielding questions from you guys out there. So if you are watching this on YouTube, you can type into the chat box, and those questions will be ferried over to us. Or if you want to tweet at Desmos on Twitter, that's at Desmos, and it'll actually be at us. So we've got what, X plus, and that looks good, great.
Pretty close, right?
Yeah.
This relative max needs to be a little higher up.
Yeah. So maybe if we just scale it, if we just multiply it by something.
Yeah, let's try a scale. So let's throw so this is where we can start a slider. So you just put in any letter you'd like, and it says add slider, and then click on the A to add the slider. I turn A. And then you can try scaling it up and down to try to get the match. And sometimes you need a little more precise control. So it definitely looks like that if you throw the A out in front, is that how you have it too, Justin? Just A sitting out in front?
I can. I was letting you do the work.
Oh, okay. No problem. So it looks like the A is going to be somewhere around 1. It's definitely not going to be negative. If that A is negative, then my cubic looks all wrong. And if the A is like up there, like 5, 6, 7, 8, it's not really going to help me. So the way you can dial in, sort of like an expert hint, is to change the slider. So I'm going to change that from, instead of going from -10 to +10, I'm going to go from 0 to 2. Clearly it wouldn't be 0. I can hit enter. Now I can sort of dial it in. I have a little bit more control to figure out where I want that graph to be. Now that I see that picture, Justin, it doesn't look like that is -6. What do you think? Do you think it's a little bit less than -6? Maybe like 5.5, -5.5?
Yeah, that's over. Right. And this is real good tinkering, right? That we want to encourage kids to do in our classrooms.
Yeah, I really love, I mean, you were talking about that before, Justin. I just love the idea that there's on an example like this, there's no real necessarily right answer. There's a lot of answers that might be really close, will all look about the same. I just think that's fantastic. I think it's a great lesson for the kids, because a lot of times in math class they think there's only one right answer, and if they don't have the right answer, then they're disappointed. It can be really an empowering moment for students to realize, hey, there's a couple different answers that are pretty darn close, and it's also pretty close to life too. I think in life you find that there's not really any one answer to a problem. It could be multiple answers. So do you think you want to adjust that one, or you want to keep it at -6? What do you think, Justin?
I bopped it over to -5.5, and I think that looks a little better.
Yeah, I think so too.
I think that's sitting here now. Oh, but the right-hand side is just not dipping low enough. You know what I mean?
Yes. So you think it's like closer to 5?
Yeah, so now this is making me want to do something like, I'm going to add this parameter, and be like, oh, maybe I'll like move you down, and do some more stretching. It's got to get, what, above 80? No, above, how big is that? 60, 70, 80, 70, got to get right above 70. Okay. Moving on down. If any of you guys out there are having good luck with figuring this out and have some suggestions for us, please tweet or chat or your suggestions.
Yeah, absolutely. So it's at Desmos, the tweet questions. All right, so what do you think? Does that look good? What do you have your A value at?
Let me look at yours. Let me look at your screen. What do you have? And what do I have?
I have the A at 1.559, somewhere around there. And I left my root at 5.5.
Yeah. Oh, so my shifting idea is not really good because now I'm going to move it off of 0. Right? My root's moved off of 0, so I'm going to get rid of that idea.
I zoom out a little bit. And it's just above 70, right? Yeah, just above 70, that peak. And that minimum is just below -30. So it should match up everything when I get it. It does. So if I get just 70, I don't have the 30 though.
Yeah,
So
I wonder
maybe it is
if
that 5 point.
Yeah, I think maybe our right hand root is too big now.
Oh, you think so?
I think maybe we overestimated that.
Yeah.
See what I'm saying?
That's going to be?
Make it smaller, right? Because that's 5, right? And so this is just a little bigger than 2.5 right now, but it should actually be a little bit smaller than 2.5, so maybe 2. Let's try 2 instead of 3. Nope, that's worse. Oh no, we can stretch it more. Here we go. No, that's worse.
Oh, try that instead of 3. Can you try 3.5?
Yeah. Oh. That looks... Does that root on the right look like it's in a good spot? Oh, my scale's a little... my counting, the numbering of my scale is a little different than what I'm seeing on Jessica's original. Okay. That looks pretty good. Right?
Totally. What do you have? So what's your equation? What's your equation?
I've got A, which is, I've got it at 1.46.
Okay.
Times x minus 3.5 times x plus 5.5. Are they pretty close to what you have?
I had something different. I had A as 1.6, so that number out in front. And I had my times x minus 3.5, and then I gave a slider for that last root, that negative root, and I got so x plus 5.31. And I get that peak at just above 70, and that negative peak just below -30. So it's one of those things where who can really tell who's closer? It's probably both good enough for what we're working on.
Yeah.
I really like that idea.
Yeah. Let's pull up another basic that has sort of a different flavor to it, and maybe we'll get to show off a little bit more of an exact solution.
Sure.
It's a different kind of thinking process. So this is 42B. All of you playing along out there. This one's by Kate Nowak. It's also a basic. Do we see it? Yeah.
Yeah, so it's 42B if you're playing along at home.
This is one of the lovely things that Desmos has built in with some inequalities. So let's pull up a Desmos window. I'll get rid of these equations and start a new one. And all right. So do you have it pulled up, Dan?
Yeah, I'm up.
So this one looks more this kind of parabolic. Yeah.
Yep.
And here the roots are a little easier to see. They look like they're at -1 and -9. So let's try that in factored form. Y equals
x.
1 and 9.
Yeah, let me get scale right. So the x for the scale looks like it's about -15 to +5. And the y is -16 to +16. So the x was -15 to +5, and the y was -16 to +16. I think that graph looks pretty good. It might be, let's see how it looks. Looks like it's going down too far, so we're gonna have to scale this. The parabola is going down too far at -5. Do you have that too?
Still getting my axes set up.
Okay.
16. I don't know. You keep talking. I'll get it. But yeah, if it looks like we need to scale it, then we should definitely do that. It looks like it's reaching all the way down to -8.
So we can scale it. And I threw an A out in front, and I bet you it's 0.5. Let me know if when you get that, if that looks right to you or not.
Slide it to make it. It said -0.5. Yeah, that looks great. And we want to shade what? We want to shade above that.
Above that, right? And we don't want to include it, the line itself. So it's what, greater than?
Yeah, so we want y to be greater than that. Or I guess I'll write that.
Okay.
But we also want it to cut off.
It's got to be
our y's.
Well, and the y's have to be less than 10.
Yeah. That looks pretty good. Ta-da! Also, I like, in the end, making them the same color, so if you click Edit, then you can click the color and then change it to
Me too.
blue. On the front page of the Daily Desmos site, if you're just scrolling through, we mostly keep to the convention that the blue ones are the basic ones and the red ones are the advanced ones. So that's one way that we signal that to people who come to the site. But there is some variation, like if we have multiple graphs, like is happening here, we might use different colors, or if there's some other good reason, then we do that, like here, multiple graphs here. Sometimes it's just fun. I made one a while ago that, where is it at? It looked like a butterfly and some grass, and so I broke the convention and changed those colors. All right, yay, we solved it. And then what people do at that point is you can save your solution. So I usually say Daily Desmos. Which one was this? I lost it. This is
42B.
42B. And I save it. And once you save it, you get this little code in your hyperlink. And if we copy it and then paste it, if we want to, in the solution. So if I go to Kate's, which actually has not had a solution posted, so then I can go here and say during and post the link. There it is. And now other people can come, and if they're stuck, then they can look and see what we did, or they can compare their solution to ours once it's done. And like I was saying before, you can come through here and say, first, click on this little arrow thing, you can change it to text. First, we roots. And I can drag this. It's all very draggable and stuff. And then I'll type a lot of expression. Y equals. Right, and so then you can build up a little discourse here, and you can type in a different thing. But
And you can see that as he's typing this in, you can see that this would be a great opportunity to send kids home and have them explain their reasoning when they try to solve something. It's a big step for them to not only get a solution, but to try to explain what they're doing. And that can be a huge help for kids, not only getting the solution, but trying to explain how they got the solution.
And so on, which I'll actually type here. and there's my solution. And if I click save, actually, if I click save, then I'm going to have a different link up here. So you should get it exactly the way that you want it, and then save it, and then post your solution, and then it'll come up like this, or you can post multiple times in the comments, and that would be fine too. What do we got next, Dan?
Next, we're both going to talk about sort of how we create the Daily Desmos puzzles.
Yeah.
And goes through quickly how we sort of come up with some of them. So I think I come at this from two different ways. Sometimes I just play around with either when I'm trying to solve a problem. A lot of times I can get other really cool solutions from that. So that's one way. A lot of times when if I'm just playing around, if I'm trying to solve it, I can get a lot of potential like advanced or basic puzzles from that. Sometimes I go from the opposite. I say I want to see a picture of a mountain, and then I go and try to make the mountain. So sometimes it's with the end in mind how I start, or sometimes it's just sort of playing around. So when I say about playing around, we can take Kate's graph solution, we can start messing with this to make this a little bit more complicated. So we can change that 10, for instance, just to make this sort of fancier. We can make that to 10, which really makes it. So 10 is probably too much. If I play around, I can get different shapes. Maybe I want to make a slider, and I want to investigate a bunch of different ways to make that graph look strange. I can add in. And then I have sort of a weird-looking graph that's all based on what Kate had. You can make sort of a weird graph that sort of modifies on what she was doing, and make it a brand new challenge. So we can change this from a quadratic. We can change this to something fancier. We can change that to like a log. Well, that's going to mess up definitely the log, but we can make it to something like a cubic. So instead of the A there, I can add in another root. X. And then I get a graph that's definitely a lot more complicated than it was before. As I go in. Really, I think, and I'm not sure, I think Justin probably would say the same thing. The more you do these, the easier it is in some ways to create, because you just sort of get an idea of what each graph looks like and how to modify it. So Justin, do you want to talk about how you approach making some of the puzzles?
Sure. So a lot of it's the same as what Dan just said. Sometimes I start with something that I have in mind that I'm excited about that I want to create. So it took me a while to figure out how to, like, I really want to find a function, or not a function, but an equation, an implicit equation that would, checkerboard the plane. And finally, I figured it out. So that took like lots of tinkering, but I came up with it. But lots of times it is really serendipitous. You try out different things and see what combinations of things pop out with. Other times, folks, including myself, but this one's handy, so I'll point it out. Try doing things that are beyond just, here is a graph. Can you replicate it? So here's one from Kate where she asks, so the 3 lines here partition the circle into 7 pieces, and then she's asking for one more line to be put in so that you cut it into as many pieces as you can, right? So it's not a single graph or a single line that's being asked for exactly. They're not trying to match something, but there could be a range of solutions. So that's something that can set up. And something that's a lot of fun is that that one of the 8 of us or some guest post will come up with some new theme or some new even genre, and then other people take that and run with it. So who was it, Dan, that first, I think it might have been you that started doing these, this one here. Yeah, so Dan had this idea of saying, well, here are just some points, and then here's the challenge up here. This challenge is different. Can you come up with a graph that goes through all 3 points? And of course, there's a whole range of different solutions that can happen there. And then there are these various bonuses that he pulled up. This is, you can see it as you scroll through the front page of Daily Desmos, but it's 17b. And then, like, whenever I saw that, that was in the back of my head. And so whenever, a week or so later, I was like, oh, cool, here's one that I made. This is 28b. And I made it with 4 points, sort of shifted over, and just trying to vary and stretch what the problem solver was going to have to do. And then the last thing, I guess, and I also use it for my advanced, where it's like, oh man, there are all these points, they're scattered everywhere, and there are even multiple copies of it up and down. So that's that thing. And then the last thing I wanted to say about the way we go about creating these, or that I do at least, is that I try to think about things that don't usually get graphed, or like in the space of all possible graphs, right? Like there's just so many different things, and we explore that space. We tend to explore a very tiny amount of that space in school, and really the tools that I have at my disposal as a thinker, as a mathematician, are also pretty small. And stumbling across new things kind of enlarges your sense of what that space is. And that's one cool thing. But there are times that I'm like, oh, what's that? Like I bet if I sort of push out this way, there'll be some new things there, and I won't have seen it before. So that's the kind of thing that happens with. What's a good example? So like this thing here. That Sam made. I remember the first time that I saw it and was like, oh, that's really different from anything that I've seen before. And that inspired me to do things later on, right? We're just trying to find something that is not going to be something that someone has seen. Make them step back and not just like take the methods that we already have in hand and plunge away with them, but like really not being sure. Right. So like, here's this thing that I made. I was trying to do something else. I was trying to. What was I trying to do? Oh, I was trying to do this. So these are paired together. This was my basic and my advanced from one day, and I wanted to make. So the basic is made with 3 equations, and like they're circles, and people know how to. Many people know how to make circles, and it's just a question of arranging them correctly. And that could be a cool challenge for someone who's just getting started with circles. But I really wanted to try to find a way to make this using one equation, right? To somehow make a polar thing so that this whole thing could be read, and it would sort of trace out part of it on the first go, and that kind of thing. And in the process, I was able to like make a polar graph that was just this circle right here, which I thought was pretty cool and hadn't seen before. And I never got to the point where I could do all three of those things, but along the way, I found that if I stuck this parameter in there, I got this cool little like squeezing through the origin circle. And at that point, I stopped. I was like, oh, I like this a lot. I'm going to post this, and maybe I'll come back someday and do that other thing that felt like sort of new ground. This was an example of where there's both trying to push out there and to see what's out there in the mathematical world, and also it's an example of stumbling across something. So yeah, that. And now we're going to talk a little bit about how we have used this in our classrooms, and also how other people have, and some ideas, some further ideas. So Dan, you want to talk a little bit about that first?
Sure. The first way I used this in the classroom, it was a day that, let me see if I can find it. Yes. The Honor Society was meeting, and it was a pre-calc honors class, and so a whole bunch of them are gone. And so the calc class, both those two classes, pre-calc and calc, were a whole bunch, like probably 80% of the class was gone for both those first two blocks. So I decided I want to do something mathy. I didn't want to just have a study hall or something. So we brought up the site, and this was about a month after we started the site, so there's a good amount of problems on there. So I had those kids that were in there. They grabbed a laptop and they were trying to solve. I showed them, the idea was they sort of were hesitant. They didn't know if they had how hard these were going to be, so I showed them ones I think they could solve, and they could get up and going pretty well. So some of these students were, when they were working on it, I gave them sort of one to start with, and they could solve that one. Then they tried to solve another one. Then they tried to solve another one, and they were able to solve a bunch of them in the end. And they would post their solutions and be very proud of posting, because it's a website. It's sort of like they feel in some way a little bit famous or something. But yeah, you can actually see in the second picture that the kid's shaking his hands. He's pretty excited. He got it. Actually, no, that's a frustration shake. He couldn't get that one yet. So he was working on it. Justin, how'd you use it in the classroom?
I haven't used it super much, just with the groups of kids that I taught this past year.
Yeah.
It was a lot of younger kids. But I did use it some with my 8th graders. There are some of, a few of the challenges on Daily Desmos that were accessible to them. And so they tried those out, and we had used Desmos a little bit in the classroom. And so we also do this thing from time to time where there's free choice, where there's a couple of different things that they can be working on. And so one day, one of those was Daily Desmos. This was pretty early on, and I told them, I was really jazzed up about this new thing. I was telling them all about it, and so some of them were working on it. And I told them, hey, if you come up with something that's really cool, then we can submit it as a guest post, or I'll even use it as one of my own. So one of my students, Sophie, an 8th grader, she was playing around with different things. She came up with this, and we thought it was pretty cool. It was like it's kind of got these X things going, and so we're like, oh, let's put it up there. And so the next time it was my turn, we did, and that was a cool experience where it was like, oh, well, there's my work, and that was fun. So that's a small way that I have used it, and it's a great way that it could be used, right? It can be this is similar to what Dan was saying. It could be sort of a spillover activity. Or it could be one of a couple of different options. We've had the thought of the possibility of using it on a recurrent basis, because it's this it's something that renews itself all of the time. We're constantly posting these new challenges a little bit at a time, and so having a day a week where, depending on what one's schedule is, or every other week, where you set 15 minutes aside for kids at the start of class to work on this kind of thing as a warm up, which segues into what we want to say that one teacher did do, which is exactly that. So let me pull up this link. So one day we got just like a ton of hits on Daily Desmos, and we were like, "What is going on?" And it was we did some sniffing around, and it turned, because like we were getting like all of these comments. Are they showing up? Refresh. Because we're getting all of these comments sort of all in a burst, and it turned out that there was a class of, were they 8th graders, Dan? Do you remember?
They were 8th graders, yeah. It was right before the coordinated geometry test, right?
Yeah, they were going to have, so Allison Krasnow was having they were having a coordinate geometry test, and so she picked out a couple of the problems from the Daily Desmos site and offered them to her students as their warm-up, and you can see all of her students down here posting their solutions, which is awesome, right? So it was a way in which this wasn't enrichment or some kind of bonus thing, but Allison figured out a way to incorporate it into the work of her classroom, and you could see how that could work for an 8th grade class in a smaller way, because there are fewer problems on Daily Desmos that are really accessible to younger kids, depending on where they're at. But certainly, like in an Algebra 2 class or in a pre-calc class, those are really sort of in the wheelhouse for those kids to try these things out, and possibly submit creations of their own.
Great. Okay. So I think we want to open it up to questions and see what you guys have to say. If you have any questions, if you want to throw any questions at us, and Eli, you can hop in and.
Absolutely. So we've gotten a few questions in. You answered a bunch of them already. Jennifer says early on, "Show me sliders," and then you immediately showed sliders. You guys are mind readers. And then there was a question about whether it was possible to graph on top of one of the Daily Desmos graphs in there. So whether you could look at the image of the graph.
So we're working on that, actually. It was an idea that came up for us sort of early on, and something that's been just really lovely about this project is that getting to work with the people at Desmos. They've been really appreciative and helpful of the stuff that we've done, and we've been able to ask them to help us with things. So there's in the works sort of a little applet kind of thing where that's exactly what would be the case, where you could put the Daily Desmos challenge would be sitting there statically, and then you could type in your different equations that would try to match to it. And then it would let you know whenever they matched up, which would be really cool. So like there's certainly something that can be flipping between two pages like we were doing just now. There's something that's it's kind of good about it, because then you're making those kinds of judgments yourself. But I agree that it'd be really super cool if you didn't have to do that moving back and forth between two screens and it was just sort of sitting there. Maybe I can. Should I pull that up, Eli? Do you mind if I?
Sure, yeah. Show people the preview. It's actually gotten better since you last looked at it.
Cool. I'll see if I can find it
this morning.
Do you have another question, or Dan, do you want to speak to that while I try to find that?
So the other questions that came in weren't questions. There was someone who said, "I love Daily Desmos." I can second that. Someone else said inequalities are slick. Agree. Bob Lachelle says, "I plan to have a station on a bulletin board where I post one each day. So we're going to take this digital world and move it back into the physical world. A little bit of regression. I love it. That's the way technology should go." Yep. And it's really this hybrid is what's so exciting to me about Daily Desmos is making it here, but you can play with it anywhere. And I like the fact even that some of the graphs you post aren't made on Desmos. It's much more about exploring the math than it is about.
Right. It's not tied. Daily Desmos isn't tied to the Desmos platform. Desmos is really convenient for us in terms of creating things. It's really flexible in terms of being able to post and share things. With the web interface for us to create the thing is super nice. The way it makes beautiful graphs, and also the fact that it's all web-based makes other people sharing their graphs with us really easy, right? Like if someone had, if someone figured this out on a separate calculator or in a different online graphing thing, then it might be much harder to share the results, and especially like that write-up thing that we were talking about before. So there's those strengths about using Desmos with Daily Desmos. But of course, you can use. We say it in every single challenge. Using Desmos or something else. Can you make a graph that's like this? All right. Yeah. So this is when we floated this idea of having the challenge graph and the solution graph on the same set of axes, and on the same screen. The wonderful folks at Desmos whipped this thing up for us. So if you type in your graph up here, and like boom, there's this thing. And then if we shift it up, that's not enough. Higher. Yay! I got it.
You were thinking
and then,
a little audio in there too?
What's that?
Yeah!
Oh, right. And maybe you can give us.
We have one more question?
Or points or something off to the side, or we can level up, or any one of those things.
Yeah, exactly.
Yeah, here all these.
Which is, does anyone have issues with people posting solutions below the graph? Does this cause students to think the problem is closed and to not try it? Have you guys seen that?
Yeah, I think there's two schools of thought there. If you go to something like projectEuler.net, which has a bunch of like math problems that you can solve with computer science and stuff, you can only get to the solutions if you solve the problem itself. So then you get a whole list of solutions. We had thought about something like that, and we're still thinking about it, but I find a lot of value in getting stuck and not being able to solve it, coming back and seeing someone else solved it, and then seeing what they have. So it's sort of like, yeah, as soon as someone posts one solution, for some of the graphs, that's all it takes. But there's also, someone posts one solution, and then there's another solution that's the picture is exactly the same, but they use a totally different method. And that's really exciting to see. There's like 6 different solutions to one problem. That's really cool to me. And I think there'd be no other. And there's something really exciting about not being able to solve one, getting totally stuck, and then coming back to it, seeing someone else's solution. And if they did something like what Justin did, where they post how they solved it, then you can actually learn a lot. And I've learned a ton about stuff I was either rusty with or I just had no idea. I've learned a ton by looking at other people's solutions. So I don't know. I think we have a lot of different there's opinions on that, but I think it's good the way it is. But it could be tweaked.
Yeah, I feel the same way. I've learned a ton from these, and I love the fact that you do have these multiple solutions. We have competitions in the Desmos office pretty much every day about trying to solve it quicker, trying to have the most elegant solution or the fewest equations or the shortest equations. Just so much fun to watch this evolve. So I just wanted to thank you guys both again for coming on today. Ooh, are there challenge graphs?
There are, yes. Okay. There's
right.
3 challenge graphs.
Thank you for coming on. I want to see the challenge graphs.
Yeah, there's 3 challenge graphs that have not been solved yet that we're going to put into the webinar link page. And if you guys solve I think the first one to solve each one of these, put it in right now. The first one to solve any one of these graphs, they're right in right now. Go ahead, and you guys have a prize for them, right?
Do we have a prize?
Mm-hmm.
What's our prize?
T-shirt.
Wins a T-shirt. Great. First one to solve each of them gets a Desmos T-shirt, American Apparel. Your choice. You can have the Desmos Man graphed by a 10th grade boy. Yeah, we've got a whole set of these. Let's see what people can do. I'm gonna be racing you. I'm gonna do Desmos shirt.
So there's some oldies, 23A, 18A, and 55B. We threw a basic in there, but I don't think it's that basic. So there's definitely some that have been up there for a while that haven't been solved. So it's not going to be necessarily easy. It's a pretty good challenge. I think we set forth for you guys. I haven't solved them myself, so I guess I'm probably out of the running, but they're tough.
Excellent. Well, we'll post those under the video. Sorry, what was that?
I was just gonna say good luck with those challenges, and hope you guys enjoy your experiences with Daily Desmos. Maybe share with your kids, maybe enjoy it yourself, and certainly if you guys have any questions or ideas about the way Daily Desmos can evolve, we would love to hear from you guys. I don't know if we have a great way of. I mean, you can certainly contact any of the folks that you see on that schedule directly. We've got our Twitter handles there. I don't think we have like a Daily Desmos email. Do we have a Daily Desmos email?
Yeah, there is. For the submissions, is it dailydesmos@gmail.com? I think.
Maybe. Is it just a form though? I think we might just have a form for submissions.
Oh, is it a form? That's a good question. Michael Fenton would know better. He's the keeper of.
We should probably go grab dailydesmos@gmail right now. Actually, I guess could we get like someone at dailydesmos.com since we have dailydesmos.com. Anyway, we'll figure it out.
Yeah, I have dailydesmos.com. We can get an email address there, no problem.
Cool.
Yeah.
All right, so you can get in touch with us. It'd be pretty easy.
Yeah. We'll share any information that we have. So great. Well, thanks so much. It's been a joy.
Absolutely. Likewise. Thank you both for coming on, and we'll look for winners of those contests and more Daily Desmos to come. Okay.